All right, we're in section 12.5 where we're going to look at volume of pyramids and cones. So a little bit different formula because of the uh, the vertex on the point. Um, what that basically does is if you were to look at um, a prism or a cylinder with the same base, it is a third of the volume of a pyramid and a cone. So that is why the volume of any pyramid or cone is a third times it by the area of the base times it by the height. Okay, so that goes for whether it's like a right pyramid or cone going straight up and down, or if it's oblique where the vertex is kind of shifted to one side or the other. As long as you have the height that is perpendicular to the base, we're good to go. So looking at our first example here, they want us to find the volume of the solid. So in this instance, we have our base is a square because of the hash marks all the way around. So that means that the volume of this one is going to be 1/3 times it by the area of the base, which is going to be 14 squared, or 14 times 14, whatever you choose to solve it, times it by the height is 10. So going over here, I got 14 squared. That gives me 196. And I got 1/3 times it by 196 times it by 10. So multiply all three of those together, we get a result of something about 653.33 cubic meters. Looking at this, we have an oblique cone, but have all the information we need in order to solve it. So volume in this case is going to be 1/3 times it by the area of that circle, which is pi 3 squared, times it by the height, which is 7.5. So again, I'm going to approximate using 3.14. So I got 1/3 times it by 3.14 times it by 3 squared, which is 9, times it by 7.5. So we got 1, 2, 3. We got 4 terms we got to multiply by. So we got, so I'm just going to go 7.5 times 9 times 3.14 times it by 1/3, which gets us to about, we got 70.65 cubic inches. All right, so in this particular one right here, we have a cube, but inside of the cube is kind of like a cutout version of a cone. So essentially what you're going to do is you're going to find that volume of the cube, and then you're going to subtract it by the volume of that cone in the inside. So going back to what we talked about in 12.4, the volume of the cube is whatever the side measurement is, and it's all 18, so it's going to be 18 cubed. So 18 raised to the third power is 5,832. Now it's going to be subtracted by the volume of the cone. Well, if you notice here, all of this is the diameter. The diameter of this is 18, which means that the radius is going to be 9. So I can now say that this cone's volume is going to be 1/3 times it by, we'll go 3.14, times it by 9 squared, which is 81, times it by the height, which is also going to be 18. So multiply all those out, I got 18 times it by 81 times it by 3.14, and I divide that by 3, and now I get 1,526.04. So I'm going to take my 5,832 minus 1,526.04, and the volume of this particular solid is going to be 4,305.96, and it is cubic centimeters. Over here we have a right cone. The issue that we have at the moment is they don't tell us what R is. They don't tell us what the radius is from the base of this cone. But we have all the information we need in order to uh, find it. So they're telling us that this angle from the base to the vertex is 70 degrees, and then they're telling us that the slant height is 8 meters. So we have this angle here. We know essentially the hypotenuse of a right triangle because that's what we have here. And then relationship to the radius of that 70 degrees is adjacent. So the trig function that we have to use is cosine, because cosine is equal to adjacent over hypotenuse. All right, remember, just to reiterate, sine is opposite. This would be opposite here over hypotenuse, and then tangent would be opposite over adjacent. Just a quick review from those trig ratios. So to find this radius, we're going to go cosine of 70 is going to be equal to adjacent, which is r, we'll call it for the radius, and then the hypotenuse, which is 8. So to find the radius, you are simply going to take the cosine of 70 degrees and then multiply it by 8. When you do all that multiplying, your radius should be about 2.74. We'll call it when we round to 2 decimal places. So now that we know what that is, now we can find the volume because it's going to be 1/3 times it by the area of the circle, which is pi, well, we'll just call it 3.14. 3.14 times it by r, which is 2.74 squared, times it by the height. Oh, we don't know what that is. But again, we can find it by using the Pythagorean theorem. A squared plus b squared equals c squared. You could also use um, the trig function sine also. Actually, let's use that. That'd be better. So you can use the Pythagorean theorem too. So let's use the trig function. So now I got the sine of 70 is equal to, we'll just call this x over the hypotenuse, which is 8. Multiply it by 8. And we got sine of 70 times it by 8, which gets us x would be about, we'll say 7.52. So my height is 7.52. So now I go over here and say this is 1/3 times it by 3.14 times it by 2.74 squared, which is 7.5076 times it by 7.52. So multiply all that out. 7 times 5.2 times 7.5076 times it by 3.14 times it by 1/3. We get a value that is about 59.09, and it's cubic meters. All right. So then here, it's telling us the volume. So they're telling you that the volume is 36 cubic feet. The base of this pyramid is a triangle. So what we need to find is the value of x, which is we're trying to find the height. So again, volume is 1/3 area of the base times it by the height. So this is going to be V is 36 is equal to 1/3 times it by area of a triangle is 1/2 base, which is 4, times it by the height, which is 6 in this situation. And then it gets multiplied by the height of the pyramid, which we don't know, and we're attaching that as x. So I get 36 is equal to, I got 1/3, and then inside the parenthesis, the area of the triangle is 6 times 4 times 1/2, which is 12. And now I get x, so 12 times 1/3 is 4. So now I got 36 is equal to 4x. Divide 36 by 4, we get x equals 9 feet. And that is being able to find the volume of pyramids and cones. Hope this helps. Until next time.